Okay, metals. Metals are so important that ages are named after them. There was a time there were no metals discovered by the early men, and that age is known as Stone Age. I mean, everything, tools, all the stuff they use was basically made out of stones because stones were easily available. But gradually men start moving around, discovering things, and they discovered some early metals. And of course the early metals were the one which were present in the nature as such, and we call them native metals, like gold, and later on gold, copper, and some other metals were discovered somehow, and they used to mix gold and copper to make a sort of better strength material, the alloy. But the real change in the civilization, in the history of the mankind, has arrived basically when the man somehow 6,000-7,000 years back accidentally converted or discovered about iron ore, and then accidentally converted iron ore into what? Pure iron. There are stories, somebody lit the fire in the cave and iron oxide was reduced to pure iron. But somehow when they find iron, they discovered iron, they later on transformed it into different tools, and they got to know about that iron got the strength. And then they start making the tools which were definitely much better operational, and the men start making different kind of weapons and different kind of things. So there were a lot of mass movement in the term of human civilizations, and also a sort of wars and territorial occupations and so much. So ages are named after the metals. Like after that initial Stone Age, we are now into the Iron Age, and from years, from centuries, because everything you made is almost containing iron, like buildings, like all bridges, and plenty of other locomotives and our weapons and all the things that contain strength. Iron is changed to steel basically, and plenty of uses. So metals, the topic basically covers properties of metals, and after knowing the properties of the metals and making certain reactivity series and extraction, application of the reactivity series, will move to extraction. Extraction of metals. Basically the extraction of metal is from metal ore. I mean that chemical reaction that leads to changing of a impure form of a metal, mean compound form, into the pure form. Okay, it's not extraction like tooth extraction. Okay, maybe for those metals the word can be, that is mining, which are naturally occurring, like gold. But like iron, it's not naturally occurring, iron oxide it is. So iron oxide turns to iron by a chemical process, we call that as extraction. We'll see in detail. But properties of the metals, we'll start with this. And we know that metals are malleable and ductile. The word malleable means molded into shapes, and the word ductile means can be stretched into wires. They are malleable, they are ductile metals. Okay, so why it is so? Why they are malleable and ductile? Because metal atoms are basically pure metal. Atoms are arranged in very fine layers. Look at those fine layers, and between them there are very fine gaps, we call interstitial gaps. Metal atoms in fine layers. Look at these layers. Similar radii they have. They have similar radii, uniform radii. So that is why pure metals are soft. A question may ask you why pure metals are soft. And you can relate that because they consist of similar atoms. They have similar radii. They are fine layers. Look at the fine layers. So they are malleable and ductile, they are soft. And when a force is applied, an external force, a suitable force, when it is applied, the layers, since they are fine layers and similar gaps in between, they are sliding away. This thing we call what? They are malleable. They have malleability. So pure metals are soft. They have fine layers, and when a force is applied, they have sliding ability. That is why metals can be changed to plenty of shapes you see all around the windows, the gates, and the plenty of utensils and stuff and surgical instruments. They have various shapes. Reason they can be molded into. They got the malleability. And you know that metals can be stretched into sheets. So metal roofing. Most parts of the world receive high amount of rain and snow. That's why roofs are made up of iron sheets, galvanized iron sheets. Stays for centuries because they are containing metals. They're made up of metals. Metals got metallic bond. We'll discuss. So first thing is they can be stretched into shapes, sheets, the wires, and the wires stay for long and long. Okay. So when we say they are malleable and ductile, pure metals are much more malleable and ductile. But sometimes we need to make metal bit harder for better purposes, and that is the reason like pure iron may be very soft and we add a bit of carbon into it, and adding other atoms into it like carbon, you'll find out the layering is disturbed. Look at the carbon atom, smaller one goes in between the gaps. As a result, you see carbon atoms. So we have iron atoms. A metal basically has changed into, this whole stuff is basically named as alloy. So many metals in pure form, they may be so soft, a little amount of other metal may be added, or carbon may be added, okay, and a non-metal may be added. Adding other composite materials sometime we can make, okay, adding some derivatives of carbon. You will find that their pure form situation of fine layering has gone, and in between them got interstitial spaces filled with smaller atoms. And when the layering is gone, sliding ability is less, they become harder. So somebody asks you why alloys are harder. Alloys are harder as non-uniform atomic radii, sliding ability is less. They got harder. Like in cars we use alloy rims, they are more harder. And also making alloys improves the weaknesses of the metal, like copper and zinc makes what? Brass. Resistant to corrosion a lot, shiny, okay, hard it is. Copper and tin makes what? Bronze. Similarly, we have other alloys like iron mixed with carbon and makes steel. And another famous alloy is duralumin. All aircrafts almost are made up of duralumin, okay, to make them lighter. And duralumin is basically alloy of aluminum and magnesium with a little zinc added. But these two things are compulsory. So they are turned into alloys to overcome their weaknesses of their softness, because layering is gone, and hardness has arisen because the non-uniform atomic radii has disturbed the normal layering fashion, and hardness is arrived, and as a result they have more strength, and as a result they are resistant to corrosion because of the other metals being involved, like some chromium may be added into iron and it becomes lustrous, or nickel may be added, or cobalt or copper may be added, so they become more shiny and lifelong and durable, okay. But iron is changed into alloys like mild steel, like hard steel, like stainless steel. We'll discuss after certain extraction of iron a topic, okay. So these are physical properties of what? Malleability and ductile nature. But metals are having electrical conductivity. Metals are used as electrical conductor.